So I made a program that simulates the abstract concepts of the 7 characteristics of a waveform. These are concepts that a lot of my students struggle with, and I tried to make some real-world applications that will hopefully help them better grasp these concepts. And here we are at the home page. It starts with a definition, and you can get to any one of these simulations from right here. So let's dig in, and let's start by looking at the pitch and volume. There are 3 concepts we're looking at in this. We have amplitude, frequency, and wavelength. So I'm going to start by hitting play, which will start the tone. And if I go to the frequency knob, the pitch will go up if I go right, and it'll go down if I turn it down. Right next to that is the wavelength, and if I start turning that, if I go longer, the students will be able to see that it goes lower. And if I turn the frequency shorter, they'll hear that the frequencies go up. And then you have the amplitude. You turn it up, it goes up, turn it down, it goes down. Next in line is the phase, and I'm going to get a little bit deeper in this a little bit later. So let's just go straight to harmonic content. When you first open this page, it starts to play the first 30 harmonics of an A2 110 Hz fundamental frequency. A grid was made by using red stripes to mark every single one of these harmonics. This makes it a lot easier to compare each of the instruments' harmonic content. In each of these videos, there were 3 different types of frequency analyzers used to compare. The first one was the average. This one is the peak and hold average meter. And then the last one is a high res, which gives you a lot more detail. To play another video, all you do is hit a button on the right over here. Let's take a look at the piano. And again, you can quickly look at all 3 different meters. And you can quickly compare the content of each of these instruments just by hitting the buttons going down the track here. And this last simulation that we're going to look at really quickly is envelope. This is just a really basic keyboard ADSR setup. You can make your envelope and then hit the trigger to hear what it is. Let's go back to home and take a look at phase. This is the most complicated of all the simulations. If we take a look at the definition, it says the difference in degrees between a point in a cycle of a wave and its origin. This is demonstrated with the first figure down here. If I take and move the phase shift, you'll see the graphic move. You'll see the origin stay in the same place and the point of the cycle, and you can see that the point of the cycle is moved, and you can see the amount in degrees on both the correlation meter and on the phase shift knob. What you can also see on the top is the second waveform moving as well along with it. This will become more useful once we get into the acoustic guitar, electric guitar, and hi-hat. I added velocity to this simulation because it has a symbiont relationship with phase. As you move the microphone, it changes the distance, and it starts to phase shift with the other microphone that you're summing it with. So far in this simulation, we've just been looking at graphics, but if we hit play, you can actually hear what happens to the phase as we change it. As I turn it down, it goes to 180 where you completely lose the sound. As I bring it back, it starts coming back in phase, and then you can hear it in full phase again. So the last knob we haven't looked at yet is a polarity invert. When I hit this knob, you'll see that the waveforms will flip. The waveform is now the inversion of what it was. So now if it was 100% in phase, it'll go 100% out of phase. The students will now be able to hear and see what this polarity invert does. This will become even more useful once we go to the real instrument simulations. Then you can flip the phase and you can actually see the inversion and change the phase shift and see that it's actually moving the distance, and changing the polarity really doesn't help the way you think it's going to help. So looking at the code, I wanted to start by looking at the index and looking at everything that it was linked for this file. These first 5 links are related to the knobs, and it's just one knob, and I got it from GitHub. So looking at GitHub, this is where I got it. And it's if we look at their site, you can see they have lots of knobs, and this is the one knob that I use. It's SVG, so I could change it to any color I wanted. Now looking back at the code, you can see I put jQuery in there. Then I also used tone.js. I use that as an oscillator. We've heard that on a couple things. And then pizzicato is what I'm going to be using for the audio for the electric guitar, acoustic guitar, and hi-hat in the phase section. Now I'll scroll down to the bottom, and I have more links down there. I made a bunch of separate JavaScript files to have it better organized, and I linked it all down here. Since we're looking at phase, I'm going to open up the JavaScript for the phase, and up here we have all the code for the knobs. Again, I used a library from GitHub, and I just tailored it to fit my needs for this program. So scrolling down farther, the next thing in line is there's the default settings for all the knobs for the phase section. Underneath that are all the declared variables. and they have their default settings as well. The first 8 variables here are getting their values from the knobs from up on top. So when I move the knob, it gives me a value, and I plug them into different equations to move the graphics and rotate the needle, as well as changing the audio. So sine figure 2, if I change the page, it's this graphic. I'm getting that from the variable sine shift. You can see right here, it plugs right into that variable. I'm changing it, and it makes that graphic move. Underneath that is sine wave 2, which is the other graphic up on top. If I scroll down a little bit farther in the code, the next one, you can see it's changed the sine needle. And I use the transform property of rotate to make that work. It needs to rotate a positive and negative 46 degrees. What made this a little bit more tricky was I wanted it to be in phase, go out of phase, and then back in phase as I move the knob. So if I bring this up to 180, and now it goes back up. So on one turn, I had to turn those numbers into 2 different directions. The knob had a value of 128, so I made an if-else statement with it. Anything under 64 would make the needle go down, and then everything above 64 would then move the needle back up. So now the needle moves both up and down on one rotation. Another variable on this equation is the phase flip. I'm going to scroll down a bit and we can look at this phase flip variable. It's on phase switches right here. This has to do when you toggle that phase polarity button. So I have the phase flip changing 4 different things when you click that button. First off, it changes the graphic up here, changes the figure down here, changes the rotation of the needle, and also changes the audio. And that's what you see right here. I have another if-else. If the image of the polarity invert switch is phase flip in, it's going to change the graphic to phase flip out. It's also going to move this graphic, and it's going to move that second graphic as well, and give me a new variable of a -1. So by hitting this switch, you can see it all happening. It changes the graphics, it changes the needle, and this -1 will give me the opposite angle of whatever is on that needle. If I scroll back up to where the change in needle is, you can see the phase flip sign right here. That's where this variable will fit in. So looking at the graphic, it's at 46 degrees. I hit the button, and now it changes to -46. The last thing I want to take a look at is the play button itself, and that's used on a couple different simulations here. And the code is just an if-else with the image changing it. If I pull the graphic out, you can see that it's actually a sprite. I have 3 different images on the same, and I'm just changing when I hover, make it active, I'm changing the distance on the left. I'll hit play, and then you'll see I did the same thing with the stop button. If I pull that out, you can see that's also a sprite. And that's what makes it look like it's animated. The main thing I would change if I refactor this would be to put it into proper OOP structure. I just kept on moving on with the program with what I knew. I never really grasped the concept completely, and I want to look into that more and actually refactor this so it is in proper OOP structure. The other thing I want to change, which is in the phase simulation, is the hi-hat. I actually want to change that to a snare drum. I often use a snare drum as an example of when you use a polarity invert button. When you put a microphone on top of a snare and you also mic the bottom of the snare, they're both facing each other and out of phase from each other. And you need to use the polarity invert in that scenario to put it back in phase. I think I chose the hi-hat just because you can hear the phase sometimes a lot better, but I think the snare drum will be a better real-world scenario. And that's all I got.